Hi guys, welcome back to my another video. Today we are going to discuss a subject about automata theory and compiler design. And the topic is non-deterministic finite automata, which is known as NFA. Introduction to non-deterministic finite automata. Non-deterministic finite automata is known as NFA are theoretically computer science models. These are the computer science models used to recognize patterns and validate input strings. NFAs playing a crucial role in the study of formal languages and are essential concepts in automata theory. These NFAs mostly used in computer science models to recognize the patterns and validate input strings plays a crucial role in study of formal languages and are essential for concepts in automata theory. Definition and characteristics of non-deterministic finite automata. NFA can exist multiple state and transitions, acceptance of strings, flexibility in design. These are the definition and these are the characteristics of NFAs. Mm. Let's see one by one. Multiple states and transition. NFS can exist in multiple states simultaneously and have the ability to transition between states based on input symbols. Mm, we're gonna see acceptance of strings. NFS can accept strings through a non-deterministic process where multiple paths can be explored simultaneously to determine acceptance. Flexibility in design. NFS offers flexibility in design and allow for complex nonlinear decisions making process, making them a powerful tool in pattern recognition. These are the characteristics comes under the non-deterministic finite automata. Mm, let's see the major difference between non-deterministic finite automata and deterministic finite automata. NFA. NFA represents two non-deterministic finite automata and DFA. DFA refers to deterministic finite automata. In NFA allows multiple possible transitions for the same input symbols leading to non-determinism. In DFA, only one possible transition for a given input symbols leading to determinism. Capable in NFA, NFA is capable for representing more complex languages pattern efficiently. In DFA, best suited for simple regular language patterns. And these are the major difference between the NFA and DFA. Representation and construction of NFA. States and transition utilizes states and transition to navigate through possible input scenarios. Epsilon transition capable of employing epsilon transition, allowing the NFA to move to a new state without consuming any input. Transition function employ transition functions to define the movement from one state to another based on input symbols. The simulation and e- execution of NFA. State configuration. Determining the possible configurations of states based on input strings and transitions. Mm, Path exploration. Exploring multiple paths concurrently to validate the acceptance of input strings. Transition evaluation. Evaluating transition and considering non-deterministic possibilities during execution. These are the simulations and executions of NFS. Conversion of NFA to DFA. In this, there are several steps which undertake to convert NFA to DFA. First step, subset construction, generating the power set of NFA states to create equivalent DFA states. State 2, state equivalence, determining the equivalence of states between the NFA and DFA to ensure a one-to-one mapping. Step 3, minimizing the number of states and transitions to achieve and deterministic representation. Applications of NFA in computer science. NFA plays a main role in computer science. Mm, 2. Lexical analysis. Lexical analysis utilized in scanning and analyzing tokens in the fields of compiler design. 5. Pattern recognition employs non-deterministic decision making in identifying complex patterns. 3. Network protocol verification used in analyzing and verifying the correctness of networks, protocols, and communications. These three are the applications of NFAs which comes under the computer science. Conclusion and key takeaway of NFA and DFA. From NFA, NFA allows non-deterministic transitions, but DFA do not. All transitions are deterministic, but in NFA it's non-deterministic. In NFA, complex representation of language patterns occurs, and DFA suited for simple regular language patterns. These these all about non-deterministic finite automata and deterministic finite automata.